Hey guys, so we've just got our second of 3 lessons on binomial expansion now, and we're going to be looking at how you do binomial expansion for things where there is not a 1 at the beginning. The formula that we've looked at, let me see if I can grab the formula up for you, is only works if you have a 1 at the beginning. This is important that there has to be a 1 at the beginning. But we want to be able to do binomial for other kinds of things, okay? So if we want to do a binomial for something that had a 4 at the start, we need to think about how this might work. So this one's asking us to find the first 4 terms in the binomial expansion of the square root of 4 plus x, and it wants us to state the values of x, which the expansion is valid. That's very common for them to do. So first of all, we need to make it look like this, and so we're going to factorize the 4 out that we've got here, okay? Right now what we have is 4 plus x all to the power of a half. And so the way that you might be able to do this is, let's just do some really big brackets for the power of a half, and we're going to just deal with this middle bit because I want it to have a 1 at this place. So I'm going to take a 4 out, and what I'd have to have there would be x over 4. Just check that that does expand to 4 plus x. 4 plus x, and that's all to the power of a half. And you're allowed to do that. Now, if you want to think about what the powers would be, well, you're doing both of these things to the power of a half. So this is the same as 4 to the power of a half, 1 plus x over 4 to the power of a half. You could, and I'm sure you'll be able to do this eventually, is you will now just know if you pull out a number, you just pull it out to the same power of the thing that you've got here. So what this ends up with is this thing that you've got outside the front is just 4 to the half, the square root of 4, which is just 2. And then you have 1 plus x over 4 to the half. Now this thing here, we know how to do this, so we can actually work out this thing that we've got. I'm going to work it out. Should I put the 2 in front? Yes, I am going to keep the 2 in front. So I'm going to have 2, 1 plus x over 4 to the half. And now it's just like what we've been doing beforehand. So I'm going to do 2, and I'll do some big brackets here. And I want to go up to the first 4 terms. That means I'm going to go and include a cubic. So I'm going to have my 1 plus, in this case, my n is a half, and my x term is now x over 4. Okay, this bit that we've got here. Sorry for this awful writing of x. So I'm going to do 1 plus n x plus n minus 1. That's minus a half there. I'm going to correct that so it looks neater. n minus 1 over 2 factorial. I'm just going to write it as a 2 multiplied by our x term squared. And I just need to do one more, which is n minus 1, minus 1 again, and you get minus 3 over 2, all over 3 factorial, which sometimes you can just write that as 6, but I'm just going to leave it in as 3 factorial, and I'm going to multiply that by x over 4 cubed. So you've just got to be really, really careful about what's positive and what's negative in this particular case. So I have 2. Okay, so here I've got a half times a quarter, so that's just going to be an 1/8 x, or I could write it as x over 4. I'm just going to write it as 1/8 x. Okay, let's think about if it's positive or negative. Okay, this bit's negative, this bit's positive, so it's definitely going to be a negative. So I'm squaring this, and I've got these two as well. So I've got a half times a half times 1 over 16 divided by 2. So that's a half times a half divided by 16, and that's the same as multiplying by 1 over 16 divided by 2. And I come up with 1 over 128, so that's minus 1 over 128 x squared. Okay, it's going to be positive or negative. Okay, this is positive, negative, positive. This is positive, so it's definitely a positive. So I'm going to do a half times 1.5 divided by 4 cubed divided by 6. And you can type that in your calculator as just 0.5 times 0.5 times 1.5 divided by 4 cubed divided by 6. You can just type that all in one line, like that kind of thing that you've got, okay? And you get 1 over 124. 1 over 1024. Didn't say that right. X cubed. But don't forget, it was multiplied by 2 at the beginning. So you get 2 plus, when you multiply all this by 2, it's not going to be 1 over 8, it's going to be 1 over 4x. When you multiply this by 2, you're going to get, I think it's 64, right? Yeah, I should be able to do that in my head. 1 over 64x squared, and what's that one? 512 plus 1 over 512x cubed. And it wanted 4 terms. Have we got them? 1, 2, 3, 4. Great. So this is approximately equal to this thing. Maybe I should have been using this symbol if I'm going to be fussy. I probably should have been using that symbol. And it was valid when we actually did the expansion. It wasn't for this thing. We did the expansion at this stage. So the thing that I need to be less than 1 is this. That x over 4 needs to be less than 1. Multiply both sides by 4. So it is valid for x being less than 4. Okay? So that's all that's different. The only thing that's different is this first stage up here that I've got written in blue about pulling out that extra term. So I'm just going to do a bit of practice of pulling out that extra term. I would like you to try and pull out the extra term of these ones. Maybe I'll do the first one and then you can pause it and try and have a go yourself on the rest. And then you're going to try and tell me when they are valid. So for this first one that I've got here, if I pull a 2 out, I would pull out a 2. It would also be to the power of minus 3. And when I pull the 2 out, I would have 1 plus x over 2 all to the minus 3. And if you want me to do that a little bit more slowly, that would be doing 2 plus 1 over x plus 2 all to the power of minus 3. So I've just dealt with this inside bit and factored out a 2, but I've gone straight to this step of just doing it to the power of minus 3. Then when I deal with this thing that I've got here, 2 to the power of minus 3 is 1 over 2 cubed, which is 1 over 8. 1 plus x over 2 to the power of minus 3. So you do binomial expansion on this, and then 8th it at the end. So this is only going to be valid if x over 2, because that's when we would be doing the binomial expansion, is less than 1. So in other words, if x is less than 2. Okay? Right, this one, we're going to pull out the 9, and please don't forget to do it to the power, okay? That's the only thing that's new here, so don't make mistakes forgetting to pull out the power. And if I take out a 9, I'm dividing this next thing by 9, so I get 2 over 9x to the power of a half. Now, 9 to the power of a half is the square root of 9, which is just 3. So I've got 3, 1 plus 2 over 9x to the half. So you do the binomial expansion of this, multiply everything by 3 at the end. Well, that means that our 2 over 9x has got to be less than 1. When you multiply this by 9 and divide it by 2, you get that x has got to be less than 9 over 2. So you can pause and have a go at these last ones, or you can just watch me do them. Okay, this one I'm going to pull out an 8. So I'm going to pull out an 8, make sure it's to the power of a third. And then it's going to be 1 minus x over 8, all to the power of a third. 8 to the power of a third is the cube root of 8, which is 2. So that's 2, 1 minus x over 8 to the third. Now we're going to see when it's valid. Well, you'll be doing binomial expansion on this thing, so we need minus x over 8 to be less than 1, which really means that x has got to be less than 8. Because remember, you can ignore the minus because of these modulus signs that you've got here. Okay, we're nearly there. We're going to pull out 5 to the power of minus 3. And that will leave us with a 1. Notice how these have all got a 1. That's the most important thing here. And I'm going to have it as a 2 over 5x to the power of minus 3. Now, 5 cubed, I believe, is 125. But the amount of time I've been off school, I don't even know anymore. So that's going to be 1 over 125. 1 minus 2 over 5x to the minus 3. So you're going to do binomial expansion on this, and at the end you multiply it by 1 over 125. So this is only valid for minus 2 over 5x has got to be less than 1. We'll ignore the negative, multiply by 5, and divide by 2. So x has got to be less than 5 over 2. I was underlining them, probably should have been consistent. And this one, I don't know if you can see that, but it's got a 16 here. Why don't I just scroll that a bit? So we're going to pull out 16, but make sure you pull it out to the power of minus a half. And then you get 1 plus 3 over 16x to the power of minus a half. Now you can put this in your calculator if you wanted to, but it's going to be the square root and the reciprocal. So the square root is 4, so the reciprocal is a quarter. 1, oh, here we go, it's a crazy pen again. My laptop is so old. A quarter, 1 plus 3 over 16x to the minus a half. Well, this is only going to be valid if 3 over 16x is less than 1. So in other words, if x is less than 16 over 3, you've multiplied by 16 and divided by 3 that we've got there, okay? So it's the same as before, but it's this first stage of pulling out the number to make them all have a 1 here and just doing it with the correct power. I'm going to do one exam question, and then I would recommend you stopping and doing exercise 4B, and then I'm going to push on and do 3 more exam questions that you can then do after you've done exercise 4B. So here it says use the binomial expansion to show that this is equal to this and find out what k is equal to. And so let's just go ahead. So we have got 4 minus x to the half. I'll pull out the 4, make sure you pull it out to the half, and then that's 1 minus, when you've pulled out the 4, you've got to divide this by 4 as well. 4 to the half is just 2. So it's 2 multiplied by 1 over x to the 4 to the half. Is this the one I've just done? It's the same apart from it's got a negative. So we'll go quick, okay? So I've got 2. Now in this particular binomial I'm doing, I've got that n is a half and my x term is minus x over 4. So it's 1 plus n x, and then you want me to go up to x squared here, plus n minus 1 over 2 factorial x squared. So that's 2. Why have I got 2 there? I should have said 1. Sorry. This is the expansion, 1 plus nx. The whole thing is being multiplied by 2. So that's 2 multiplied by 1 minus an 8x. I'm just going to quickly work out what this is. Well, this is going to be positive, this is going to be negative, this is going to stay negative. So it's definitely going to be a negative. Positive, yeah, that's correct. So I've got a half times a half divided by 4 squared divided by 2. So that's minus 1 over 128 x squared. Multiply everything by the 2, and you get 2 minus a quarter x minus 1 over 64 x squared. So k is equal to minus 1 over 64. Then it says here, a student attempts to substitute x equals 1 into both sides of the equation to find an approximate value for root 3. State if the reason if the expansion is valid for this. Well, we did the binomial expansion for this particular thing that we had here. So for part B, we know that it's valid for the modulus of x over 4 being less than 1. In other words, if x is less than 4. 1 is less than 4, so the expansion will be valid. Okay, so I recommend you having a go at exercise 4B. I'm just going to double check we've got this right by looking on the mark scheme. I think you should probably stop here and come back to this to do some exam questions on this topic, because these are all the exam questions we've got. So yeah, we did get k is minus 1 over 64, and we said that x equals 1 can be used. So you may like to pause here. I'm going to push on and just do 1, 2, and a half. I'm not going to do all of that question. And I think that's us done. Okay. So this one wants me to show the binomial expansion of this is equal to this thing, and it wants me to find out what this bit is here. And then we're going to do some approximating in that second bit. So let's go nice and quick. We've got 4 plus 5x to the half. Well, I'm going to pull out the 4 and raise it to the power of a half, and that'll be 1 plus 5 over 4, making sure these have both been divided by 4 to the half. Well, we know that this is just 2, and so that's 2, 1 plus 5 over 4x to the half. So in this particular case, our n is a half, and our x thing, and I always put x in this inverted commas. I've just had enough of this slow laptop, I tell you what. And our x, because it's different each time, is 5 over 4x. So scroll down and give me some room. So 2 outside the front. 1 plus n x plus n minus 1 over 2 factorial x squared. Squaring the whole thing, okay? So I'll leave the 2 outside the front, and I've got 1 plus 5 over 8x. And then just really carefully, what I've got here is I've got a half times a half. Oh, I should have decided it's obviously going to be negative. So I've got a half times 5 squared divided by 4 squared divided by 2 factorial, which is just 2. And you get minus 25 over 128x squared. Don't forget to expand by multiplying by the 2. So we get 2 plus 5 over 4x. Let's just multiply that by 2 as well. Minus 25 over 64x squared. Let's just see if that's what they've got. Yeah, they got the 2, they got the 5 over 4x. So it looks like k is minus 25 over 64. This is where it gets a little bit more interesting. Use the expansion from part A with x equals a tenth to find an approximate value for root 2. Give your answer in the form p over q, where p and q are integers. And then explain why this is a valid approximation. So really it's just saying it's going to be a rational number, okay? Just express it as a fraction. So they're asking us to substitute in x equals a tenth into 4 plus 5x. Oh my god, this is too much today. You can hear me if I was doing this at school, I'd be screaming at the board. So we get 4 plus 5x to the half. And they've said that it's approximately equal to... I've got it right in front of me. 2 plus 5 over 4x minus 25 over 64x squared. So first of all, I need to investigate what is happening on the left-hand side when I substitute in x equals a tenth. So the left-hand side, if x equals a tenth, would be 4 plus a half to the half. So that's 4.5. That's 9 over 2, sorry, 9 over 2 to the half, which we know is the square root of 9 over 2, which is the square root of 9 over the square root of 2. So it's 3 over root 2. God, I just probably should have put this in my calculator. Let's just actually do that. So let's do the square root of 9 over 2, and you get 3 root 2 over 2. So it's got something to do with root 2, but they wanted it to do exactly root 2. So we better just kind of stick with this for now, and we'll work out what the right-hand side does, and then we'll keep going. So the right-hand side, when x is equal to a tenth, would be this thing. So that would be 2 plus 5 over 4. Oh dear. 5 over 4 multiplied by a tenth. What was coming up? Minus 25 over 64 multiplied by a tenth squared. Now I'm probably just going to put a tenth in my calculator as a decimal. So that's 0.1. I'll store it as my answer. So that's 2 plus 5 over 4 times the answer minus 25 over 64 times the answer squared. And we get 543 over 256. So we know that the left-hand side and the right-hand side are equal to each other. So we've got 3 root 2 over 2 is equal to 543 over 256. And they want to find out what root 2 is. So solve the equation. Multiply by 2 and divide by 3 to get root 2 by itself. So I'm going to multiply that by 2. I'm going to divide that by 3. And you end up with 181 over 128. Well, let's just check to see if this makes any sense. The right-hand side as a decimal is 1.414, and that's just with 3 decimal places, and root 2 is 1.414. So we've definitely done this question right. We can see that everything is correct that we've done here. They are approximately correct. So what have we got here? P and Q are integers. So this was our answer. P is 181. Q is 128. And then part 2 of the question says, why is this valid? Why is this a valid approximation? So our approximation, when we did the expanding, was at this stage that we had here with the 5 over 4x. So we know that 5 over 4x, it is valid if the modulus of 5 over 4x is less than 1. So that means that x has got to be less than 4 over 5. And a tenth is less than 4 over 5, so it is valid. Let's see if we got the answers right. Yep, we got the minus 25 over 64, and we got 181 over 128. Is that correct? 181 over 128? Yep, we did. And what else have we got here? Yep, it's got to be less than 4/5, and that's true, so it's valid. Okay, one last proper question, and then the last one is I'm just going to do nice and quick. So here we need to do the binomial expansion again, and it just says to find out what a is equal to. Find the value of a, giving your answer in simplest form. But k is a constant, so we don't actually know what k is going to be. So we might need to do some comparisons here. Let's just deal with it with k, and then we'll compare it to this afterwards. So 6a, our function is 2 plus kx to the power of minus 4. Now to do that binomial expansion, I've got a 2 here, which I don't want. So I'm going to have to do the 2 to the minus 4. I'm going to have to factor out that 2 and leave it as 1 plus kx over 2, all to the power of minus 4. Now 2 to the power of minus 4 is 1 over 16, and then I've got 1 plus k over 2x to the power of minus 4. So here our n is minus 4, and our x value, this thing that we've got inside here, is going to be our kx over 2. Now we only need to go up to x squared, so it's not going to be too much work. So I'm going to leave the 1 over 16, and I have 1 plus n x plus n minus 1 over 2 factorial, which I can just leave as 2, x squared. So here we get 1 over, let's just leave the 1 over 16 for a second, sorry. I've got minus 4 multiplied by kx over 2. Well, that's just going to be minus 2kx, okay? And then here, it's clearly going to be a positive. So I've got 20 divided by 2 and then divided by 2 squared. So that's 20 divided by 2 divided by 4, which is 5 over 2. And it's going to be a positive 5 over 2. Careful with this, you're squaring it. K squared, x squared. So when I expand, I have 1 over 16. Great, that's what they have. Then I have 2k over 16. Well, 2 over 16 simplifies to 1 over 8, so I get k over 8. Just think about that. That simplifies to k over 8x. And then when I've got 5 over 2, if I divide that by 16 as well, I get plus 5 over 32 k squared x squared. Now, I want to find out what a is, but I don't know what k is. But I do know about these two things that I've got here. So if I compare coefficients, I can see that 5 over 32 k squared, the bit that's going in front of the x squared, must be equal to 125 over 32. Okay, because the coefficient of x squared here is 5 over 32 k squared, and over here is 125. So I can multiply both sides by 32 and divide by 5. So that gives me k squared is 125 over 5, which is 25. And so k is going to be plus or minus 5. However, does it say anything? It says that k is a positive constant. So we can say, but k has got to be greater than 0, so k is equal to 5. Now we can find out what a is. So we get a is equal to minus k over 8, which is minus 5 over 8. I don't know if you can hear this, but my laptop is so hot it can't cope. So it's minus 5 over 8. Okay. Found out the value of a. Determine, giving a reason for your answer, whether the expansion is valid when x equals a tenth. Okay, well, we did the expansion for this thing. The expansion that we did, let's go to a different colour. We actually did the expansion on 1 plus, now k is 5. We did it on 1 plus 5 over 2 x to the power of minus 4. So the thing that we're interested in is that 5 over 2x has got to be less than 1, which means that x has got to be less than 2 over 5. So 2 over 5 is 0.4, 1 over 10 is 0.1, so you can say 1 over 10 is less than 2 over 5, so the expansion is valid for x equals a tenth. I'm giving up. Let's check our answers. So we ended up with the a is minus 5/8. Yep, that's what we got. And it is valid when it's less than 2 over 5. And yep, it's valid because a tenth is smaller than 2 over 5. So we got that correct. Okay, this one I am not going to do the first part of the question. I'm not going to do this bit here because I think it's really straightforward. It just says find the first 3 terms of this binomial expansion. 4 easy marks. What I wanted to talk about was this thing that I've got here. It says the expansion can be used to find an approximation to root 2. Possible values of x that could be substituted into the expression are minus 14 because you would get root 2 over 6, so you could multiply the right hand side by 6, x equals 2 because you'd multiply the right hand side by 2, or x equals minus a half because you could multiply the right hand side by 3. But without evaluating your expansion, state giving a reason which of these values should not be used. Well, if you just think about what's happening, if we factored out the 4 that we would have had, we would actually have an x over 4 has got to be less than 1. In other words, it's only valid if x is less than 4. So the one that we can't use, if you look at these ones, is this minus 14. So the one that should not be used is x equals minus 14 because expansion is only valid for x being less than 4. State, give me a reason which of these 3 values of x would lead to the most accurate approximation to root 2. Well, I wonder if you remember this from a few slides ago. The ones that are the most accurate, the smaller values of x, provide the better approximation. So our smallest value of x that we have here is between these two. I think this one is going to be the smallest. So which of these 3 values would lead to the most accurate approximation? X equals minus a half because it is the smallest value. So it gives most accurate. Okay, let's just double check that we got those right. Can't use this because the expansion is valid for x being less than 4 and the smaller value gives the more accurate approximation. So we're going to stop there. I know that's been a really, really long video, but hopefully you've come back to finish those off. Thanks guys, see you later.